Hello, good morning from Spain. I am Álvaro Villegas from Nokia Bell Labs, and I'm going to give you a presentation in this workshop about a completely new way of doing trainings using immersive media. Let's start. Okay, let's first start describing the limitations of the current technology. Imagine a virtual reality training application like this flight simulator that you see in the image. When you're playing with it, it may be very complete and very nice, but you still have a ghost feeling when you're inside the application. You don't see your body, you cannot touch real stuff. So it's nice, you can learn things, but it's really strongly limited in terms of the learning capabilities that it can provide. Why is that not enough? Why virtual reality is not enough? We think that mostly a very important limitation is that you can only provide a representation of your hands and in the scene, so it's just an avatar of your hands, and the things that you touch are not real. You cannot really touch things. You cannot see your hands, you cannot see the tools and the things which you should be doing your training. That's a strong limitation. But then you can wonder, why not using AR, which is designed exactly for that, for using real stuff around me. That's true, but with state-of-the-art goggles today, you have very strong limitations. First of all, the field of view is very limited. You have all experienced that. And on the other hand, the occlusiveness, I mean, the capability of changing dramatically the world around you with something else, which is really important for training, is simply not possible. To overcome these limitations, we have created something called distributed reality, which is a technology that tries to merge two or more different realities. One is your own local reality, so as you can see here in the picture, you can still see your real hands, your legs, your body, parts of the things that you have in your hands, objects, tools, if you're doing a training with real tools and real objects, and the rest of the environment can be changed with something completely different, maybe something remote captured with an immersive camera, or it may be, of course, an immersive application developed for your virtual training. And what we call real haptics here is the possibility of adding real objects to the scene that you are experiencing, meaning that you can touch real things that are around you, and we can keep their original appearance or dramatically change it, as you can see here on the right side of the picture. Hands are real, the table that the guy here is touching is real, but the appearance is completely different. Imagine the power that has for training applications. Here you've got an example. On the left side you see what you really have in your hands, which is just a cardboard with some QR codes. On the right side you have a tablet, a cardboard tablet that you can fully control with real video. So let's give a few examples of how this can be applied to real training. You can see here a few use cases in the military or safety space. The one at the bottom right is a very nice experience of doing work at Heights, in which you can train your people that need to do real installations with real tools, complex stuff that in real life will be done in a very high tower. But you cannot do that with a virtual training. With distributed reality and real haptics, you can do that. You can provide the real feeling of doing that complex technical work while really being at a very high place. Let's get another example with a remote driving application. On the left side, you have the typical cockpit with the screens providing the view for driving. On the right side is the distributed reality equivalent. The hands and the steering wheel are real, are local. You're touching them and you're controlling them as in a real car. The car cockpit can be generated by a computer application, so that's virtual. And what you see through the windows is something which is either captured from remote cameras or generated by your training application. Okay, so we have a nice new technology and we have to test it. That's the next step. Instead of designing a boring test, we decided to make it fun and design an escape room experiment with some puzzles that the user had to solve in less than 5 minutes. What you see on the left side is the real objects that the user can touch and manipulate for solving the puzzles. What you see at the right side is what the user really experiences when inserted into the game. So the architecture for implementing that is based on an Oculus Rift goggles with a mounted set mini stereo camera used for capturing the egocentric view of the game. For filtering the hands on the objects, we are using a simple color-based algorithm, and to track the objects whose appearance has to be changed during the game, we use Aruco library. The game itself is written in Unity. We carried out a complete experiment last October with 53 users. Each of them spent 30 minutes playing the game twice, once with the distributed reality and the other one with a pure virtual reality, so we could compare them. And then at the end of each play, they filled a complete survey. After the experiments, we used the information derived from the questionnaires to evaluate the validity of the distributed reality and the real haptics technologies compared with purely virtual reality versions. And we evaluated both the subjective feeling of the users about the presence, the embodiment, the quality of the experience, and also the objective usability of the system, how fast or how well they were able to solve the different puzzles. The conclusions are fully explained in the paper that is presented in this workshop, but in summary, the conclusions were the following. First of all, the results showed that the experiment has an ecological validity, meaning that people didn't even realize that they were doing a scientific test. They were just playing an escape room and they had fun, and that is very good for getting good results. Those results showed that consistently everyone considered distributed reality with real haptics as much better than the virtual reality counterpart. The ownership of their own body, the way in which they could control stuff with their hands, with their real hands and real objects, was considered much better than a pure virtual reality experience. And finally, it was very interesting to see that people enjoyed the experiment, and some of them were even willing to pay for it. Nice. So the main conclusion is that this technology is really useful for next generation training applications. I let you now enjoy the video that shows you the experiment. Thank you very much.